Okay, so to finish this yesterday, we were putting the inverse tangent of x into our calculator and y equals. If you have stat plots on from stats, you'll have to turn those off now because you can't have that. Inverse tangent of x. And I think you're going to want zoom trig when you set it up. So that's what that graph looks like, okay? Because normally tangent does something like this. It like goes up and curves like that. So this one's going this way, and so that's why the domain for that would be all real numbers. It might be beneficial just to look at inverse sine and inverse cosine just for reference, because obviously those could come up on the AP exam, and I don't know that it would be on a calculator section. So let me see. Well, that's inverse cosine. I guess those are technically restricted from probably, well, I was going to say 0 to pi because that's where that restriction is anyways, but maybe not. I'm not sure. And that's sine. So sine and cosine are basically just flipped of each other still on that. But I'd be more worried about the inverse tangent one, to be honest. But. Okay. So, continuing on. Okay. Number 8. dy dx is equal to e to the x minus y, and y is equal to 2 when x is equal to 0. Now, what is technically my first step with these problems? Yeah, so I need to get the x terms on one side and the y terms on the other side. Any idea how I can do that given this particular situation?
Something like when we have the and then we raise everything to the e, can we do something kind of like opposite that?
So not yet. We wouldn't be able to do that because we still have this stuff over here.
Right.
I could only really do it with this side. But is there a way that I can rewrite this so that I can separate these exponents of x and y? That's not going to help me yet either. Okay, let me see if I gave you something like this. If I gave you x squared times x to the negative 5, what would you do to simplify that? Subtract them. Okay, normally it would be adding, but since they're subtracting. So this would be x to the negative 3. Right? Or x to the 2 minus 5. So work backwards, and what do I do with this?
X times e to the negative y.
Yes. So dy dx is equal to e to the x times e to the negative y. And then what can I do with it? What am I allowed to have negative exponents? So what do I do?
Put it on the
Put it where it ain't, make it positive. So dy dx is equal to e to the x over e to the y. And now what? So now I would have e to the y dy is equal to e to the x dx. Now I would integrate both sides. So what is the antiderivative of e to the y dy?
E to the y.
E to the y. How about e to the x dx?
E to the x plus c.
Plus c. I feel like this is going to end up being the same problem we had the other day. I think we need to do the plus c up here. Because then we can do the process that we did the other day, right? So then I can do the ln of both of those. Well, I guess it's technically the ln of those things. So I guess we did it in the reverse order the other day. But the ln of e to the y would just be y. Then the ln of e to the x plus c would just be x plus c. So then 2 is equal to 0 plus c. Actually, I think we need to do it. The plus c should be on the like side over here. Just disregard that part. Because the other way was the opposite when it was we had ln and we undid it with an e. So this is different. Okay, so then we would have e to the 2 is equal to e to the 0 plus c. E to the 0 is what? 1, so that's going to be e squared is equal to 1 plus c. So e squared minus 1 is equal to c, which we could find that number, which should be like 7 something, I think. But the book will just leave it this way. Or 6.38, so yeah. So the book will just leave it like that when they replace it, and then end up with e to the y is equal to e to the x plus e squared minus 1. And then we need to get y by itself over here. So now we would take the ln of both sides. But when we do this, we have to remember this is everything. So this would become y is equal to the ln of e to the x plus e squared minus 1. And then if we were so inclined, we could do, well, actually, never mind. I just kidding. Different thing. We would leave it there. And then what values does a log function take on for domain? All real numbers. All right. In exercise 19 and 20, find the amount of time required for a $2,000 investment to double if the annual interest rate R is compounded A annually, B monthly, C quarterly, and D continuously. So basically we're doing this problem 4 times. So 20, they give us the percentage rate in the actual problem of 8.25%, which is what is a decimal? And then the amount that we start with initially, so the A sub 0 is $2,000. They gave us that in the problem, or like in the question. That was like the instructions, I guess. I don't know. And then we're looking for it to double. So the A of T, which would be the final amount, to be $4,000. And we're trying to see basically how long it's going to take for that to happen, with it compounded under different circumstances. So A says that it's compounded annually, so what does that mean? Once a year, so K is equal to 1. So our formula, I'll write it this first time, and then after that we'll just use it to plug in, I'll write it up here. A of T is equal to A sub 0, so that's the initial amount, times 1 plus R over K raised to the KT. So we have every piece of information we need except for T, which is what we're solving for. So I start plugging in. So 4,000 is equal to 2,000 times 1 plus 0.0825 divided by 1, and then raised to the 1 times T. And then we would just need to solve this. So 1 plus 0.0825 raised to the T is equal to 2. 4,000 divided by 2,000 is 2. And I wrote it this way so that I can do what? How do I solve this? The L?
Yeah.
So it's an exponential, so I use a log to solve it. So loop it through. So I have log base 1.0825 of 2 is equal to T. And then you get to use your lovely calculator to find that number. Remember where log base is? This room is so hot. .74. And what are my units?
Years.
Yep. Unless otherwise stated, it'll always be years. Now, still the same initial numbers and all this stuff up here that I wrote in black. But question B says that if it is compounded monthly, so what does that mean K is?
12.
K is 12. So 4,000 is equal to 2,000 times 1 plus 0.0825 divided by K, which is 12 in this one, raised to the 12T. So, you're gonna want to actually figure out what this number in here is. So this is gonna be in parentheses 1.006875 raised to the 12t is equal to 2. Use the L. So log base, and if you don't, like, if you've already found this number and you don't have to like type in the super long number again, if you hit second and then the negative sign, that's answer, it'll pull that answer in for you, so you don't have to retype it. And then when you find whatever that log value is, you need to divide by by 12. 8.43 years, yes. Okay, C. Is quarterly, so how many times is that? 4. So same thing, 4,000 equals 2,000 times 1 plus 0.0825 divided by 4 raised to the 4t. So this is going to be 1.020625 raised to the 4t is equal to 2. So then log base that whole number of 2 is equal to 4t, and then just divide that number by 4. Now the last one says continuously. So that's a different formula altogether. It's the formula A of t is equal to a sub 0 e to the RT. So 4,000 is equal to 2,000 e to the 0.0825 times t. So this would be e to the 0.0825 t is equal to 2. Then use the L to solve. So I get, it's log base e, so ln of 2 is equal to 0.0825 times t, and then you'll just divide to get t. So what do you notice about all these numbers?
All pretty similar.
They're all pretty similar.
Just a symbol.
Yeah. So the one that takes the least amount of time is the one that's done continuously. And then obviously monthly is a little better. Which, I mean, it makes sense, right? And with a bigger amount of money, like, you would probably notice it more of a difference, but $2,000 to $4,000 isn't, I mean, it is a big difference, but it's not like a drastic difference. So you'd probably see it better with bigger numbers, but that's what they gave us, so here we are. All right, a half-life problem now. So this is actually a word problem. It's on page 361 if you just like want to turn there, but you don't really need to. I can just read out the stuff that you need out of the problem. An isotope of neptunium, NP240, has a half-life of 65 minutes. If the decay of NP240 is modeled by the differential equation dy dt is equal to negative k over or negative ky, where t is measured in minutes, what is the decay constant k? So notice in this one they tell us that t is in minutes, so that would be how we know. Otherwise we just assume years with that. So the half-life is 65 minutes. And then the differential equation they give us is dy dt is equal to negative k times y with t in minutes. And we want to know what k is. So we got the half-life equation in your notes yesterday. That's the equation that says half-life is equal to ln of 2 over k. So then we're going to do, the half-life is 65 is equal to the ln of 2 over k. Then I can swap k and 65 to solve, so k is equal to the ln of 2 over 65. And then what is that? Point 0.01 what? 1. Oh, do you round it?
Yeah.
Oh, okay. And that's just what k is. There's no units on k. It's just the decay constant. All right, we're going to do one more, and then we're going to stop because after that, paper on fire. Because after that, I think we get into the stuff that's Newton's law of cooling, and I would rather just wait and do that when we get back. Do that and then review, and then we'll probably test either. We'll see how we're feeling, if we're ready for it Tuesday, but maybe Wednesday that week we get back. So, 24 is a bacterial growth problem. A colony of bacteria is grown under ideal conditions in a laboratory so that the population increases exponentially with time. At the end of 3 hours, there are 10,000 bacteria. At the end of 5 hours, there are 40,000 bacteria. How many bacteria were present initially? So At 3 hours, we have 10,000 bacteria. At 5 hours, we had 40,000 bacteria. So our formula for this is does it say what our growth constant is? Pretty sure I don't know. Disregard that. Okay, so our formula for this would be y is equal to y sub 0, which is just our initial amount, and then e raised to the kt So by using the numbers that I'm given, I can find out what my decay or growth constant is. Okay, so what K is. Because I have all the rest of the stuff. Because in this period of time, how many hours have passed? Well, from 3 to 5. 2. So T is going to be 2 in this case. So I'm going to have 40,000 equals 10,000 e to the k times 2. So e to the 2k is equal to 4. So then using my L ln of 4 is equal to 2k. So k is equal to the ln of 4 over 2. And so then now I can go back and try to find what the value was that I started with. It's going to look a little different because I started at hour 3. I didn't start with the initial, and I'm trying to figure out what my initial was. So when I'm doing my K value, make sure I say this right. No, when I'm doing T, we just found K. When I'm doing T, I have to go back to the initial starting time, which would have been like 0 hours. But how do I get from 3 hours to 0 hours? By subtracting 3. So now in this problem where I'm actually trying to solve it, T is going to be negative 3 so that I can get from hour 3 back to the initial time of 0. So we're going to have y is equal to 10,000 e to the negative 3 times the 0.693 number that you had. I don't know if that was rounded or not, but I'm guessing it probably was. Usually they are. So, I mean, you might be off by like just a little bit because of it being rounded unless you use just the second answer button when you type it in. But by plugging this in, we will get our initial amount that we started with of bacteria. Okay. 1,250, and that would be bacteria for the units on that. So we can specify what that was, but that would be all you have to do for that. Okay, I'm gonna go ahead and give you some problems, but if you won't finish them now. You do not have to do them over spring break. You can just wait till we get back to do them because we have a little bit left in the section to do, and then we'll review. I would say most likely the test will not be till Wednesday when we get back, so we have Monday and Tuesday to finish up and to review. So problems at this point. 1, 3, 5. 9, 19. You don't necessarily need to do A, B, and C, but you need to at least do one of them, and then also D, because D is continuous, which is a different formula.
Right.
And then as far as half-life, which one did we do? Did we do 22?
Yeah.
Okay, so then 21 is you're actually finding the half-life in that one, so you're not finding the same thing. But 21 and then 23 for bacterial growth. And then, like I said, we'll do this stuff with Newton's law of cooling when we get back. It's pretty much the same stuff that we were just doing. I mean, it looks the same, but there's like formulas and stuff that goes with it, and it explains what it is and all that fun stuff, so.